Hey, welcome. Today we're going to dive into a short but wow, incredibly deep idea that kind of challenges how we see everything. It's all about the tools we use to make sense of reality and, maybe the limits of what we can even know. So our whole journey today is going to circle around this one big question. Just let that sink in for a second. When you come across something that just doesn't fit, how do you know if it's just plain wrong? Or if maybe your understanding is the thing that's incomplete? We're going to unpack this together.
All right, to get our heads around that massive question, we're going to start with something that sounds almost ridiculously simple. We're going to talk about lines. And believe it or not, this basic concept holds the key to the whole puzzle.
Okay, first up, the word continuous. Imagine you're drawing a line on a piece of paper. You put your pen down, you draw, and you don't lift it up until you're done. That's it. That line is a single, unbroken, smooth thing. No gaps, no jumps, just continuous.
Now let's flip that on its head and talk about discrete. Think about stepping stones across a river. Each stone is its own separate spot, right? You're jumping from one distinct point to the next. The important part is the space between them. It's not one smooth path. It's a series of individual parts. And here's where it all comes together. A real line, one you'd find in nature, is continuous. But a number line, the thing we invented in math class to measure stuff, that's discrete. It's made up of individual points, 1, then 2, then 3, and all the little decimal points in between.
So you see the problem, right? There's this fundamental mismatch. We're trying to measure a smooth, unbroken reality with a tool that works by jumping from point to point. The very system we built to understand the world is fundamentally different from the world itself.
So you might be thinking, okay, lines, number lines, what does this actually have to do with anything? Well, this is where it connects to the real world, to this relationship between the rules we invent, like mathematics, and nature itself.
Now check out this powerful idea from our source. Part 1. Nature is not ruled by mathematics. We tend to think of math as this rigid set of laws that the universe has to obey, but this is suggesting something else is going on.
And here's the second part that just flips everything. But mathematics is enabled by nature. Whoa! That's a total paradigm shift. It's saying math isn't some rulebook we force onto the universe. It's a language that the universe gave us. It grows out of nature.
So what does that really mean? Well, think of it this way. Mathematics is a language. It's a language we came up with to describe the beautiful patterns we see all around us. Nature provides the symphony, and math is our attempt to write the sheet music. And you know what? It's incredible, it's powerful, but it's an approximation. It's not the music itself.
Okay, so we've got this idea of a continuous reality versus our point-by-point tools. And we've got this idea of nature enabling math, not the other way around. With all that in mind, let's go all the way back to that big, tricky question we started with.
The big takeaway here is absolutely huge. Our tools, and that could be a number line, a scientific theory, whatever, they literally define what we're capable of seeing. You know that old saying, if all you have is a hammer, everything looks like a nail? It's exactly like that. And this slide just lays it all out perfectly. 1, reality is this smooth, continuous thing. 2, we create a discrete point-by-point tool to try and measure it. And 3, the big consequence, our tool, just because of what it is, will always miss the infinite number of points in between. Between the number 1 and the number 2, there is a literal infinity that our step-by-step system just hops right over.
Which leads us to this really cool question. Does that make the number line wrong? No, of course not. It's unbelievably useful. We build bridges with it, we send probes to other planets. But maybe wrong is the wrong word. Maybe it's just an incomplete map of the territory.
And so here we are, right back where we started, but we're looking at the question through a totally new lens. How can we tell apart a wrong idea from one we haven't understood yet? Given everything we've just talked about, what do you think now?
Maybe the line between wrong and misunderstood isn't a hard line at all. Maybe it's just a matter of perspective. A wrong idea could just be a sign that our current tools, our current maps, are too limited. We call it an error because it doesn't fit our model, when what we really need is a new model, a new way of seeing.
And I'll just leave you with this final thought to chew on. What if those ideas out there that seem completely crazy and wrong today aren't wrong at all? What if they're actually maps for a territory our current tools just can't see yet, just waiting for us to find a new way to read them? Thanks for digging into this with me.